Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's Advanced DBA meeting. So we have with us the pleasure of Dennis Torres talking to us about parameter-sensitive plan optimization. So please, take it away.
So, welcome everyone. Thank you for attending this session. So, my name is Dennis. I'll be talking about parameter sensitive plan optimization, a new feature in SQL Server 2022. So, this is me. I'm a trainer. I live in Malta. I'm the Malta Data Platform User Group leader, and these are my contacts. It will be a pleasure to stay in touch. LinkedIn, Twitter, on any social media. To be a pleasure to stay in touch. So, first, before talking about the PSP itself, let's understand its needs. It comes to solve a very old problem we have called parameter sniffing. What is exactly parameter sniffing? So, we need to remind the basics about execution plan. We send the query to SQL Server, the query is compiled, and the compilation creates an execution plan. The execution plan can be parameterized. This means that if the execution plan has a where looking for a specific value or some other criteria, that criteria can be parameterized. So similar queries with a different value can still use the same execution plan. So the execution plan can be parameterized. The plan is stored in the query plan cache, exactly to be reused. The compilation time takes some effort from the machine, from the server. So it's not good if you have queries compiling all the time, recompiling all the time. So the compilation time is not perfect. So a good solution is to have the plan reused. So the plan is reused for multiple parameter values. That's the solution that we expect. But we have an exception for this scenario. The problem is the execution plan good enough for any parameter value? The plan which was generated when the query arrived, is it good enough for any value that appears for that parameter, that specific parameter? Or it isn't. Let's analyze what kind of situations it may be good or maybe not. What makes a plan good for any parameter value or not so good for any parameter value is if the value that we are talking about is evenly distributed among the rows of the table, or if it is not evenly distributed among the rows of the table. Let's consider the supplier ID that you are seeing on the screen. Let's imagine that I make a query with a where by supplier ID. I'm searching for a supplier ID. The IDs of the supplier are evenly distributed. I have a similar number of rows for every supplier. So it doesn't matter if I'm looking for the supplier ID 2, the supplier ID 4, supplier ID 3, the amount of rows returned will be very similar. In this case, a plan built for a query like this, a query over a column like this, that will be good and also will be perfect for any parameter value. But what would happen if our column is not evenly distributed? Is the opposite, unevenly distributed. Let's see this example. This example I'm extracting from a table that I have on SQL Server, where the supplier ID is totally has a totally different number of rows for each supplier. In fact, I have two supplier IDs which have a huge number of records, while all the other suppliers have a very small number of records. What happens? The query plan, which is created for a small number of records to return a small number of records, can't be the same query plan that is created to return a huge number of records. There are many differences that these plans need to have in relation to how they use the index, how joins are made, how sorts are made, the amount of memory which is allocated to execute the query. Many differences are needed between these two, let's say, two kinds of plans. A plan to return a small amount of rows and a plan to return a huge amount of rows. So in this case, a single plan doesn't solve this problem. In fact, when we face a situation like this, uh, using a single plan for this scenario makes it way worse. This creates the scenario that we call parameter sniffing. Let's imagine a query like this, where I'm making a query filtering by supplier ID equal to. The query arrives on the server, and the compilation happens, and the query plan is created and put on the cache. The query plan created is created according the value which arrived for the parameter on the first query, on the first execution. So the query plan is created for the value of supplier ID equal to. Then after that, some minutes later, uh, another query arrives asking for the supplier ID 4. What will happen is the absolutely same query, just using a parameter value which is different. So the plan will be recovered from the query plan cache and used to execute this query. However, the amount of records that the supplier ID 4 has is completely different than the amount of records that the supplier ID 2 has. These are two completely different amount of records. So the plan which is in the cache and was built for the supplier ID 2 will be extremely bad to execute this query with the value for the supplier ID. That's the problem. That what is called parameter sniffing. When the query arriving, the first query arriving, makes the plan be compiled with the value of the query, and this plan may not be good enough for any value in the table. So we depend on our chances. We may have good luck and a good parameter arrives and the plan ends up not being so bad. Or we may be in a bad luck day, a bad parameter value arrives on the server, results in the plan compilation, and that terrible plan will be reused for every value. Possible solutions which were already tried for this problem. Microsoft is trying many solutions, and this is a problem so old, but so old that some solutions come from SQL Server 2000. So, possible solutions which are tried. If we are using store procedures and the store procedures use parameters, our store procedures usually receive parameter values, then we can apply a with recompile on the store procedure. But mind what I'm saying. I'm not saying that you should apply with recompile to every store procedure. Because for some of them, the columns may be evenly distributed on the tables and it's okay. The with recompile is only needed if the store procedure suffers this problem of parameter sniffing, which is caused by columns which are unevenly distributed in the table. Then you should apply a with recompile. It's interesting to highlight this because I already saw, for example, some development environments, database development environments where developers were creating store procedures and they set as a rule, let's always use with recompile on the store procedure. That's not something that should be done. You may be avoiding some parameter sniffing problems in some stop procedures, but you are forcing a lot of recompilations that are consuming resources from your server. So that's not good. The ideal solution is to use something like this when it's needed. Another similar solution: use the option recompile as a query hint in a specific query, not in a stop procedure. In a specific query, you can use option recompile. Again, you will only do something like this if you are absolutely sure that query really suffers of parameter sniffing, and you need that query to always have a new plan depending on the parameters of the query. Other options: adaptive joins. I'll not go deep on this. This is a feature released on SQL Server 2017, which allows a query plan to dynamically choose the kind of join that that query plan will use. The query plan have a special operator, the operator for adaptive joins, that will dynamically choose one join type or another join type. So this avoids some of the problems of the parameter sniffing. I mentioned that depending on if we are returning a small amount of rows or a huge amount of rows, one of the details affected is the type of join that should be used. So Microsoft provided the feature called adaptive join that can dynamically choose the type of join. That made some improvements, but not for everything. Memory grant feedback. Another thing I mentioned. I mentioned the amount of memory allocated to return a small amount of rows. Oh, or the amount of memory to return a huge amount of rows, they are very different. They are completely different. And if by mistake one is mistaken by the other, what happens? What happens is a spill to TempDB. The data is sent to TempDB for the processing to happen in TempDB. It can be a sort spill, a join spill. The data will go to TempDB and the query will be very slow. Microsoft tried to solve this kind of problem using the memory grant feedback. How this feature works? How the memory grant feedback works? It identifies when the amount of memory allocated for a query plan is not good enough. When it identifies it? After the execution. After the execution of the plan, it identifies, oh, this amount of memory was not enough, a spill happened. Or the opposite. This amount of memory is too much. Too much for this query. This query doesn't need all this. So what happens is a process of feedback. A feedback is hashed, and then on the next plan execution, the amount of memory will be fixed. It helps a bit, The problem is that in critical situations of the parameter sniffing, the amount of memory needed may be changing all the time. Maybe not. Maybe only a few suppliers have a different number of rules. Maybe this doesn't change so much and this ends up solving a bit the problem. It's possible. But if the amount of memory keeps changing all the time, one query arrives with a parameter that requires a lot of memory. Then the feedback increases the memory. Then the next query arrives with a parameter that doesn't require that amount of memory. Then the feedback reduces the amount of memory. Then again, a parameter that requires a huge amount of memory, a lot of memory, increase again, then reduce again, then increase again, then reduce again. What will happen? There is a limit on the memory going feedback, which is 32 feedbacks. If it reaches 32 feedbacks for the query, it just stops. It's deactivated for that query and will not make memory going feedback for that query anymore. So the most critical parameter sniffing situations are not solved by the memory going feedback, and the adaptive join may not be enough as well. Option recompile and with recompile are possible solutions that will make us exchange one problem with another. We will avoid using a bad plan by forcing a constant recompilation of the query, which will demand some effort from the server. We are changing one problem by another, and until recently, until before SQL Server 2022, this was acceptable. Yeah, let's change one problem to another because using a bad plan is absolutely terrible. So with the compile is a bit better if we use correctly. Let's see the demonstration about this problem, how this problem happens, how this problem is solved, before we dig into parameter sensitive plan optimization, the new feature of SQL Server 2022. So, I have here a SQL Server with some demo database here. So I have some copies of the wide world importers, which I will be using for this demonstration. Okay, let's start with the parameter sniffing demonstration. I'll use wide world importers too. First, let's say that I will clear the environment. I will clear the cache and clear the query store for this database. So let's take a look on this query. I'm declaring a parameter, supplier ID, setting the value as 4, and executing the query. And on the query below, I'm declaring the parameter with a different value and executing the query. So let's see the actual execution plan. The ID4, the supplier ID4 has a huge number of records. So it will take about 1 minute for this query execute. This gives me some time to explain why this code is a bit different than the code you saw on the slide. Why I'm not using just the number here on the query. Because that's not what happens when an application sends the query to the server. When the application sends the query to the server, the application does this by parameterizing the query. The queries the application sends are parameterized. Oh, what if you are using an object relation mapper, like Entity Framework, for example. What if you are using some kind of framework like Entity Framework or Hibernate or some kind of development framework like this? There is a special stop procedure, which is the SP execute SQL, which is used to parameterize queries in this way. These queries arrive on the server as an execution of this stop procedure. So they arrive parameterized to the server. So I'm simulating a parameterization of the query. So this first query was executed, and the result for this plan is a cluster index scan. So it made a scan on the clustered index. Okay. What happens if the value is 2? The problem is not related to the value is 2. The problem is that now that the plan is compiled and it's stored in the query plan cache, it doesn't matter the value anymore. The query below will use the same plan using a clustered index scan. So this query below will also use a clustered index scan. It has a way less records to return, but it still used a clustered index scan because the plan was cached. The plan was stored in the query plan cache. Let's see what happens. So, first let me mention this. The cached plan was the plan for the huge amount of rows, the return of a huge amount of rows. With the supplier ID, we said the ID 4. This made this plan be repeated to the next one. The opposite could happen. The first query to arrive could be for the value 2. And then the plan for the query with value 2 would be reused for the supplier ID 4. That could happen as well. Let's see. One of the possible solutions that I mentioned is to always use option recompile. This is one of the possible solutions. To always use option recompile on a query that we know that suffers of this problem. If we know that this query suffers this problem, we use the option recompile. See? It was way faster because now this query was capable to use the index seek. You can still doubt about the result because this is the first query executed after I cleaned the environment. So this plan would be on the cache and would be reused for the next query. Not a chance. The next query is slow because the supplier ID 4 has a huge amount of records to return. That's why this next query is slow. But the plan is defined according to the query because it's being used the option recompile. We are using the option recompile on the query. So the resulting plan that we'll see as soon as it finishes to execute and return in this huge amount of rows is for the clustered index scan. The first query with the 2 used the clustered index seek, which is a way better plan for this query, while the second one will use the clustered index scan, which is the standard for this amount of rows and the lack of any other better option. So just a few seconds more completed, and we can see the execution plan using the clustered indexes scan. So the point is, we executed each one after another, and the plan from one was not reused on the other. Is a solution for the problem? It could be a solution for the problem because using the bad plan would result in a terrible execution time, absolutely terrible execution time. So this could be a solution for the problem. But we are exchanging one problem by another. Instead of using a bad plan, now we are forced to recompile every time this query arrives on the server. We are forcing the recompile on every one of these queries that arrive on the server because we are developing with this hint. So, as a result, we are putting some heavy processing on the server. We are putting some heavy processing on the server with the compilation. Okay, so this is the problem. And what I'm saying since the title of the session is that we have a new feature called parameter sensitive plan optimization, which brings a solution for this problem. Finally brings a very good solution for this problem. What is this? What this means? In summary, this means that in SQL Server 2022, we can have multiple query plans in the cache, in the query plan cache for each query we have. It's not about having one plan for one query. No, we can have multiple plans for each query. This is made based on query statistics. So, who takes the decision about having multiple plans for each query is SQL Server. SQL Server 2022 will take the decision to use PSP or not for one specific query. And this will be based on the query statistics. Why? Why is this based on the query statistics? Well, I mentioned before the root cause of the parameter sniffing problem. What's the root cause? The root cause of the parameter sniffing problem is the distribution of the values. If the values are evenly distributed, you don't need multiple plans. But if the values are unevenly distributed, then you need multiple plans according the amount of rows returned depending on the parameter. It doesn't depend on query store. Why I'm saying that it doesn't depend on query store? We almost haven't talked about query store on this session. It's because parameter sensitive plan optimization is among many query optimizations which were released together SQL Server 2022. And most of these optimizations depend on query store to work, but not PSP. PSP doesn't depend on query store to work. If query store is enabled, if query store is enabled in the database, it will make a good use of query store, but it doesn't depend on query store. When the multiple query plans are created for the query, two types of query plans are generated in the query plan cache. One dispatcher plan. One of the types is one dispatcher plan, and the other are variant plans. So we have one dispatcher plan and many variant plans. Let's talk about this. The variant plans are defined by the range of returning rows. Exactly what I'm telling from the beginning that creates the problem of the parameter sniffing. The amount of returning rows. If one parameter value returns a small amount of rows and another parameter value returns a huge amount of rows, those two parameter values can't be have the query can't have the query executed by the same plan. That's the point. And the variants are defined by the range of returning rows. How is this structure between dispatcher and variants? The dispatcher plans is the plan that will stay in the cache and it's responsible for starting the execution. This is the dispatcher plan. So when a query arrives on SQL Server, this query, the query optimizer checks the query plan cache to see if there is a plan compatible with this query. The plan that the query optimizer will find is the dispatcher plan. The dispatcher plan triggers the execution of a PSP scenario, a query with multiple execution plans. And the dispatcher plan decides which variant plan should be executed. So the decision of which one of the variant plans should be executed is made by the dispatcher plan. If a variant doesn't exist yet to support that execution, a compilation will be done and a variant for that execution will be created. And the variant plans. The variant plans are the specific plans that are compiled to support a range of returned rows, a specific range of returned rows. Something like if the amount of returned rows is up to 100,000, then this plan can be executed. If it's above 100,000 but less than 500,000, then this other plan needs to be executed. So each variant plan will be for a range of returned rows. It's created when a query for that range of returned rows is executed. When a query for that range is executed, the variant is created. If no query for that range appeared in the server, that variant may never be created. And the variant is triggered by the dispatcher plan. So the dispatcher plan triggers the execution or even the compilation of the variant plan if the variant doesn't exist yet. Let's see an image. One image talks more than 1,000 words. So a parameterized query arrives on the server. The dispatcher plan is triggered. The dispatcher plan on this example is linked to 3 variants. So one variant is made for if the amount of records returned is less than 10,000. Another variant is made for if the amount of records is between 10,000 and 1 million. And the third variant is made for the amount of records returned above 1 million records. So the variants are compiled according to the number of records the parameters will return. So it's not one variant by each parameter value. No way. No way. When the parameterized query arrives, the dispatcher analyzes the statistics to check this value will return which amount of rows. Oh, this value is about to return this amount of rows. Then decides according to the amount of rows which variant will be executed. And you are seeing three variants here. Why you are seeing three variants here? You are seeing three variants because for each parameter that a parameterized query can contain, three it is the maximum number of variants that can be created for each parameter that a query contains. 3 is the maximum number of variants that can be created. Let's see a demonstration of this. Let's see how this really works. Let's see this in practice. So I have here the parameter sensitive plan optimization. I open the wide world importers, clear the environment again. I'm clearing the cache and the query store. I'm clearing both cache and query store. So I'm clearing both. And I have here a store procedure. Just to be a bit different. The previous one I did with a script, and now I'm doing with a store procedure, but the result ends up being the same. However, this database wide world importers is enabled for PSP. What makes it enabled for PSP? Or what makes the two not enabled for PSP? The compatibility level of the wide world importers 2 is on SQL Server 2016. That's why PSP was not triggered when I did the first example. Otherwise, I could not even conclude the first example. The PSP would have triggered. But now, on the wide world importers, the compatibility level is SQL Server 2022. So compatibility level needs to be SQL Server 2022 for PSP to be automatically triggered. I don't need to do anything. It will be triggered, and we will face this when analyzing the query optimization. When analyze the plans for a query, when looking the query plan on Query Store, we will face multiple query plans for the same query. That's what will happen on this scenario. Let me execute the first one. Let's get the actual execution plan, which is using an index seek. So the actual execution plan for the value 2 used an index seek, exactly like the previous example. And now I used execute the stop procedure again for the other value, for the value 4. It's already returning data, but it will take a bit more time to execute. It will take a bit more to execute. After finishing the execution, once we finish the execution, we can check the query plan. We can go directly to the cache, query plan cache, and look for query plans using PSP. To go to the query plan cache and look for query plans using PSP, we need to use XML queries. Let's just check the query plan after the execution. See, the parameter 4 is using a clustered index scan, but not using a clustered index scan. It decided to make the execution in parallel. It's even interesting because it decided to make the execution parallel to optimize and finish the execution in 37 seconds. The previous one, with compatibility to SQL 2016, did not try to execute in parallel, and as a result, it took more than 1 minute and a half. This one execute in parallel, okay, took 37 seconds. Okay. So I was talking about checking the query plan cache, so we can use XML queries to check the query plan cache. We use the sysdm exec cache plans to retrieve cache plans. And I need to retrieve the plan and the query text using cross apply. And then I'll filter by this database and check if inside the query plan I have one specific node on the XML, the dispatcher node on the XML. All PSP plans will have this dispatcher node on the XML, so I can find the plans in the cache by looking for this dispatcher node. And here I can find 3 plans. And these 3 plans, they are created for the absolutely same query. But you can notice the difference. The first thing you can notice about the difference between the dispatcher plan and the variant plans is the query text. The dispatcher plan gives us the exactly text of the query itself, which, since I executed the stop procedure, the dispatcher plan gives us the stop procedure code. But the variant plans give us the codes, the text of the specific query inside the procedure, which has the problem itself. The problem with parameter sniffing that required 2 query plans. Here, I'm looking to the query plan column. I can open one by one. The dispatcher plan appears like this. If you look to a query plan and you see this, multiple plan, the multiple plan operator in a query plan. What this means? This means this is a dispatcher plan in a query that was optimized using PSP. So this query has multiple query plans in the query plan cache. So this is a dispatcher plan. Okay. And the other ones will be the specific execution plan for that piece of query. One is the index scan with the execution in parallel. And the other one is the index seek for the small amount of rows. And the absolutely same query has 2 plans. I need to increase a bit the space in the middle for everyone to note that this is the absolutely same query, but with 2 plans. And the query optimizer will decide which plan will execute by using the dispatcher plan. The dispatcher plan will be triggered and will decide based on statistics which variant should be executed, which variant plan should be executed. But there is more. It's interesting to note what is included on the query text of these plans. There is a query hint. A query hint was included on the variant plans option plan per value. The object ID involved on this in case the table. Then the query variant ID. I said before, each parameter can have at most 3 variants. So the variant ID is important. Identify the variant ID is important. So one is variant ID 1, the other is variant ID 3, and we are missing variant ID 2. The first thing that we know, since we are missing the variant ID 2, is that a third plan could be created in this PSP optimization. If needed, when needed, a third plan could be created. Perfectly possible. The third plan would have query variant ID 2. But an interesting question would be why these IDs, these variant IDs, are 1 and then jumping to 3? Why is that? Let's analyze the rest of the hint and we will get this. We have the supplier ID. Supplier ID is the parameter that these variants are handling. So these variants are created to handle the supplier ID parameter. And we have a range. But we have two numbers, 100, and if I'm reading correctly in the zeros, it's 1 million. 100 and 1 million. Only two numbers. And the two numbers are the same for both variants. How does it work? The two numbers are the same. So what makes the difference? What makes the difference is that the two numbers are defining the range for 3 variants. 3 variants. And the ID of the variant defines which one of the 3 variants is this. Which one of the 3 variants is this plan made for? So the ID 1 means that this plan with query variant ID 1 is made for queries which return less than 100 records. Queries which return less than 100 records can use the variant 1. The variant 3 and not 2, 3 is made for queries that return more than 1 million records. If a query returns more than 1 million records, so it will use the variant 3. And the variant 2, of course, the variant 2 would be made for a query which were returning something between 100 and 1 million records. If your query returns between 100 and 1 million records, then this query would use the variant 2. Since this hasn't happened, it didn't happen on this scenario, we don't have a variant 2. So it's really extremely interesting how now on SQL Server 2022, a single query can support multiple query plans. using this structure of dispatcher and variant plans, and this is a great solution for the parameter sniffing problem. Is this a full solution for the parameter sniffing problem? Many would say, no, it's not a full solution for the parameter sniffing problem. Okay, may not be a full solution for the problem because we are still limited to 3 queries for each parameter. 3 queries for each parameter. Well, but if we face a specific scenario where the 3 queries are not enough, it is still possible to combine different features. For example, the plans, the variant plans created here could be using adaptive join, for example, to avoid some problem of the parameters different. So a combination of multiple features could be used to get the PSP, reaching a great solution for parameter sniffing. So if this is not a final solution, at least the parameter will be reduced and will be reduced a lot to the level that to simulate a parameter sniffing scenario, I had to reduce the compatibility level of the database, otherwise I would not be able to simulate the problem. SQL Server 2022 would not allow me to simulate the problem. And one detail that I mentioned before, I mentioned that PSP doesn't depend on Query Store. It doesn't depend on Query Store. But if Query Store is enabled for PSP, we have some advantage. We have the advantage that the plan is hashed on the Query Store history. And I don't need to go to the Query Plan cache to check the PSP plans. I can, for example, query another DMV called sys query store query variant. This will list which queries we have hashed inside query store, which are variant plans. So variant query ID 38 and 39. It's telling us that the query ID 38 and 39, they are variants in relation to the dispatcher query, which is the query 37. The dispatcher query is the query 37. Okay. So I can look at the variant queries. I can look on the query text of the variant queries, making some joins with query store query text, and joining together the query variant. I'll be looking for the variants and making the join with the variant, looking for the variant ID. I'm looking for the variant queries. So I look for the query text of the variants, and I'll see exactly the same that we faced before in the query plan cache. The exactly same query test, including the query hint that we faced in the query plan cache. Another query here I can use to look to the dispatcher query. In this case, I need to look to the parent query ID. I need to look to the parent query ID, which is the dispatcher query for these variants. So I'm looking to query 37. In query store, it shows me the select different than this is different than the query plan cache. It shows me the select, but without the query hint. Without the query hint. And this is the dispatcher query hashed in query store. And I can also look on the dispatcher plan. I can use the query store plan to retrieve the dispatcher plan, cast it as XML, and I can look to the dispatcher plan and we see the multiple plan, the same that we saw before when analyzing the query plan cache. So that's it. This is the great new PSP, parameter sensitive plan optimization in action in SQL Server 2022. That's the idea. So thank you very much for attending this session. It is a pleasure to be here. Thank you for the invitation to deliver the session. It will also be a pleasure to stay in touch. You have my contacts. Everyone attending has my contacts. Feel free to keep in touch. And I'll leave some time for questions.
Excellent. So we do have one question in chat. The question actually is around how you mentioned there are up to 3 variants, and do you know why why 3 is the maximum number of variants? Is there some inherent reason, or was it just like 3 is a good number, or how did that come about? Do you know?
Is I can only put a guess on a question like this. I can only put a guess on a question like this. That this is related to the query hint, the format of the query hint and the format of the dispatcher. Let me open it here. The query hint is established in a way to define 2 values as a limit. So the defined architecture where the range is specified is a range of 2 values, the amount of rows returned. So as a result of this architecture, naturally for each parameter, you have 2 variants. The starting one, the starting variant, the one in the middle, and the bigger one. The bigger one. So it's related to the architecture of the query hints, but this is a guess. If there is any other reason for they to choose 3, I don't know for sure. But I can add a bit more answering this question. I can add that there are some very specific documentations available telling that it's not this 3 is not about having 3 variants. Because I said you can have 3 variants for each parameter, but on each query, you can have up to 3 parameters using PSP. So it's not that you have only 3 variants per query. You have 3 variants per parameter, but on each query, you can have up to 3 parameters using PSP. So again, something that is just a guess, the kind of number that Microsoft could change at any moment and is not even mentioned in any documentation. It's just a guess from my end. I would guess that since we have 3 up to 3 variants and up to 3 parameters on each query that can receive a variant, there is a maximum of 27 variants per query. A maximum of 27 variants per query. 3 for each of 3 parameters.
Okay, yeah, thanks for that.
Combinations of the 3 parameters. But it's a guess. It's a guess. I can't. This calculation is not documented.
Yeah, that's fair. I'm sure that there's some developer somewhere within Microsoft who could give the official answer, but uh, whether or not that developer would be allowed to give that answer, who knows?
Yes, that's the point. They like to keep this number so they can easily change if they need.
Right. Um, Next up, there was a question: Have you had a chance to try this out in production, and have you noticed any performance differences?
SQL Server 2022 is not is very recent. I had not a chance to test the 2022 so broadly in production yet. But what is expected is a natural performance improvement once you put your queries on the correct compatibility level. Once we put it on the correct compatibility level, what we expect is a natural performance improvement. I mean, it's impossible for the DBA to track every parameter sniffing situation, every parameter sniffing case. So once you put the correct compatibility level, checking how many variants are created, how many PSP situations are created in a store, in Query Store, for example, is even a way for the DBA to look, there was it and I was missing that parameter sniffing problem. It's almost impossible for the DBAs to get out of that. It's very difficult. So we're passing this task to the server and is expected to have a good improvement in relation to this.
Got it. So there's another question here in chat. I guess there was a memory dump issue with parameter sensitive plan optimization in SQL Server 2022. And do you know if CU5 has fixed that issue or?
No, this is a very specific information. I'm not completely aware about that. I'm not completely aware if CO5 fixed it. But it's not difficult to find the list of fixes on a CU, and that's the kind of the reason why you need to always keep the cumulative updates up to date. Always apply the cumulative updates, the most recent cumulative updates to avoid situations like this. But no, unfortunately, I don't have a precise answer for this.
All right. Yeah. And Marshall's response there. I guess we'll just have to try it out and see what happens. Yeah.
Yeah.
There may be some information in the notes, but even when there are bug fixes in there, whether or not it's your exact memory dump, unless you have an issue open, um, we'll see.
Yeah. Difficult to identify precisely.
Right. Sure. All right. If there are any other questions for Dennis before we wrap things up, get them in chat. And Mala mentions that this actually is something that she tweeted about this morning. I guess it turns itself back on after it's turned off. At least it's what Mala has been experiencing. So that's kind of interesting. But not sure what the circumstances there are.
Oh, sorry, I missed which feature turns back on.
Yeah, that PSP optimization after she's turned it off somehow turns it back on. Maybe installing the CU was the thing that turned it on. Not quite sure.
It's possible. It's possible. This one I may be able to track a bit, but if they would like to send me an email, feel free to send me an email about this one, about turning off and on again. Maybe I could track this. Feel free to send me an email, drop me a message.
Sounds good. All right. So I think we've got all the questions now. So I guess I'll wrap things up for the evening. Thank you kindly for a great presentation, Dennis. Appreciate getting this overview of how parameter-sensitive plan optimization has kind of been implemented and some of the ways that it can work. Much obliged. And remember, everybody, that we've got 2 more presentations this month. Next week, we have our main meeting. 2 weeks from now, we have our data science and business intelligence meeting. Our main meeting will be hybrid, in-person, and remote. And 2 weeks from now, remote only. So get all that at meetup.com/trypass. And until we see each other at some future event, everyone, take care.